Hey, what's up, guys? Welcome back to our channel. Today we've got something really special for you. We're introducing the Event-Driven Federated Subscriptions, EDFS, at WonderGraph. This new feature is a game changer for real-time data handling in your applications, bringing a whole new level of efficiency and flexibility. Stick around because Jens, my co-founder, will be jumping in with an awesome demo to show you EDFS in action. You're going to love how it transforms the way you work with data. For more insights on this feature, you can check out our blog post in the description. Let's get started.
Hey, my name is Jens. I'm one of the founders of WonderGraph, and in this video I want to talk about event-driven federated subscriptions. So this is a demo, this is an explanation how it works, why we're doing it, etc., etc. First of all, we have composed a federated graph. So you can see the config here. We have a bunch of subgraphs. We can locally compose that. So I have a compose here. VGC router compose, then I put all the inputs, I get my config JSON, and I pulled out the schema from that. You can see here what's relevant is we have a subscription type, it has a field employee updated, and then that returns an employee. So if I go type employee, you can see here that's the whole employee type, ID, role, details, etc., etc. So that's our federated graph. Then what's relevant here is here on the left is our subgraphs. So we have one in particular, the employee updated. That's our kind of virtual, I call this virtual subgraph because it's not really a subgraph. It doesn't live on any subgraph. It actually lives on the router. And what it does is it allows us to connect our router directly to an event source. In this case, we're using NATS, but you could also use Kafka, SQS, anything. So how does it work? We have three directives and they behave slightly differently. So we have events request, events publish, events subscribe. So here's a query. We can use events request, and that sends a inbound query to a topic. It creates a response topic, and then if the service answers to this response on this response topic, we get the data back. And you can see here we can use args.id. So this is args ID. So we're actually rendering this topic using template syntax, so that if we send something like ID1, then it would be get employee.1 would be the topic. We can also do mutations. If you look at this, we have an events publish directive. What it does is it takes the whole input, JSON encodes it, so it would have an ID and then update with name and eval. It JSON encodes that and sends it to update employee.1, for example, if you put 1 here. Finally, and I think this is going to be the most used one, we have the subscription type here with employee updated. So we can do events subscribe. So this simply subscribes to a topic. If we put employee ID 1, then it would be employee updated.1. And whenever there's a new message, we resolve that. You can also see one specific semantic here that's very important. You can see that we use the key directive on the employee type. So we tell the Cosmo Router that this is an entity. And we tell it also that we are expecting the ID field to come back from the topic. So that means if you want to send a message to this topic, it always needs to contain the ID and also the type name, because in entity land, you always need to identify an entity with __ type name. For example, it could be an interface or a union. In such a case, you need the entity. Okay, how does it work? Let me see. So here we have a Cosmo Router. We run that. You can see it's running. Static configuration, it's connecting to NATS. Great. And if I restart this here, you can also see from a system point of view, we use 70 megs of memory and 0 CPU and idle. And we can also see Go routines, top 5. I'm using pprof here, 31 Go routines. And we can also check the heap, top 5. And you can see 5 megs of heap to start up. So it's quite small. All right, let's subscribe to our thing here. So I have a playground. Let me move that over. Here's my playground, and I want to subscribe to employee updated. How do I get rid of the docs like that? Okay. So I subscribe, and you can see nothing is happening. Why is nothing happening? Because we need to wait until the first message that gets on the topic employee updated .1. So how can we do that? Let me see. I have a nuts client here, and I think I need to publish. So if I publish a message on employee updated 1 with a JSON object type name employee ID 1, that should trigger our message. And you can see that here. I can do this again, and you can see how the updated at is changing. So the time is changing. Each time I send an event that invalidates the subscription. And what you also see, we query details, role, updated at, etc., etc. So we query additional fields, but these are coming from our subgraphs. So what Cosmo Router does is it takes type name employee and ID 1, and then it starts additional entity requests to fulfill our requests. And so it's a regular GraphQL query. We can join data from all our subgraphs, but it's triggered by an event source. In this case, it's nuts, but this could be Kafka, SQS, anything. So we also have other options. We can trigger the availability or an availability update. We can also do that via a mutation, because one of our subgraphs, it implements this. It has a nuts client, so if I send a message here, you can see, let me see. We're not subscribing anymore. Okay, let me subscribe. And now you can see, pop, pop. Each time I make a mutation, that sends a message to the topic, and this works as well. You see, exactly same thing. Okay, that works great. Then what else can we do? That was subscription. If you look at our schema, we also have the request. So the request works in a similar manner. We can query an employee from event. If I look at the schema, here's employee from event, this one. It requests an employee from the get employee topic with args ID. And then once we get the type name and ID back, we can resolve it. So how does it work? We need to send a reply. So here's our nuts client. We reply on getEmployee.1 with this information. And now if I open this here and query it, you can see that we received a message, and this is what we sent back. And details, it's being fetched from a different service, because here we're not sending details. So that is coming from a subgraph. So again, we can extend a root field, or we can add a root field using our event source. The third option is we can also have a fire and forget. So this is an events publish. It simply returns an publish event result with a success boolean. And what it does is it takes the whole input, JSON encodes it, and sends it to update employee topic. So if I subscribe here to update employee and then wait, and I go back here and then update employee. You see here we have an ID1, name Jens, and Jens at WonderGraph. If I send this, you can see here, this is what we're getting on our event source. So this is a simple mechanism how you can publish data to an event source from a client using a mutation. All right, so you might be thinking, why are we doing this? Why did we go all the length to implementing this, and why does the existing solution of subscriptions, why does it not work? So there's 3 problems. You can also go to wondergraph.com/blog, and then you click on the currently first blog post. It's called Announcing EDFS, Event-Driven Federated Subscriptions. And here we describe 3 problems. 1, subscriptions make subgraphs stateful. Second, subscriptions can only have a single root field. Third, a lot of frameworks are quite inefficient when it comes to CPU and memory usage with a lot of subscriptions. And I show you what that means in a second. So let's tackle the first one. Subscriptions make your subgraphs stateful. So if we look at this here, let's say we have the subscription, and let's say a client connects to our router, and then it connects to our subgraph. What it means is, we can delve into this here. So we have a client that goes to router, router goes to subgraph. In this case, the client creates a WebSocket connection or SSE to the router does the same thing, it creates another WebSocket connection to the subgraph. That costs some resources, but the main problem here is that it creates a stateful connection between router and subgraph. So that means if we deploy our subgraph in a serverless environment, for example, there's limitations on how long that can run, like a few minutes or I don't know, it really depends. But in any way, you have limitations where you can deploy that, and you have long-running operations. Like that means you have a connection open to the subgraph, even though there might not be any data. But yeah, so that complicates the deployment, and it kind of limits where you can deploy your subgraph. And ideally, your subgraph would simply be stateful. So the router sends a request to the subgraph answers that in a few milliseconds or a couple of seconds if it takes longer, but then the connection is gone. And that means you can update the subgraph more frequently. You're not killing connections so easily because let's say you want to update your subgraph 1, 2, 3 times a day, and you have open WebSocket connections. So what do you do with these connections? Do you want to kill them? Do you want to have them reconnect? If it's just one-off requests, you can have like a rolling restart where you rolling restart all your subgraphs, and then after a couple of minutes you have updated all subgraphs, and meanwhile for each subgraph you can gracefully wait until there's no more requests from the router to the subgraph, and then you can cut it off and then switch traffic to another one. So that's one of the problems. The second problem is subscriptions can only have a single root field. So if you look at the schema here, type subscription, this one. Let's take employee updated as an example. So I can have 2 services or more that influence fields on the employee type. And that's the whole point of federation. So if you go type employee, you can see we have ID, role, hobbies, products, notes, is available, current mood. And for example, is available, we have one subgraph who manages the availability of a user, of an employee, and we have another subgraph that manages the current mood. These are just example subgraphs, but you get the point. Details is coming from another service. So if we have a system like federation that allows us to combine data from different subgraphs and to share ownership of employee fields across subgraphs. That's great. It makes our company scalable. On the other side, and I go back to type subscription. If on the other side we use subscriptions, it means this root field needs to live on some subgraph. So if an employee needs to be updated and this field is owned by a subgraph, there's going to be always a dependency between the subgraphs, because the owning subgraph of this root field, it needs to be informed to invalidate the subscription or to re-render it or something. So that's a huge problem. And in our case here, what we do is employee updated. It is not tied to subgraph. It is tied to the event source using the event subscribe directive, and it's tied to a topic using this argument. So that means any subgraph that contributes fields to the employee type, whenever a mutation comes in and we change the mood or we change the availability, each of the subgraphs involved, they can send a message to the topic that invalidates this subscription for a particular entity. And that means, again, even for subscriptions, we have shared ownership of the entity. We have shared ownership of the root field, and everybody in our landscape can send messages to these topics to invalidate subscriptions. And that is not, we're not limited to doing that with subgraphs. We can even have like a long running process that is like a background job. And when something changes for an employee, and this change data is reflected in our subgraphs, we can after that send a message to this topic, and then it would invalidate all the subscriptions running on our router, and the router will refetch all the data from our subgraphs. So that means we can have federated subscriptions driven by events, and it's still very scalable across our teams, and we don't have to coordinate across subgraphs when to invalidate an entity. And that means not just from a technical point of view, it's hard to coordinate between these services, but also from a logistical point of view or process point of view. You don't have to coordinate between the teams, because you can simply agree upon, okay, here's our virtual subgraph. We have an entry point for updates on employees or updates on a chat room or something. And then whenever one service thinks that the chat room should be invalidated or an employee should be invalidated, they send a message done. All right, that's the first two items. The third one is resources. So if you look at the resource consumption, the client connects to the router. That's one WebSocket on the client. Let's just forget about the client for a moment, but the router will have a WebSocket handler. And for a WebSocket handler, you need two things. You need two threads, kind of. One thread where you read or you wait for messages coming from the client, and one thread that is able to write back messages to the client. That's on the router. And then once the router subscribes to the subgraph essentially needs the same thing. So for each client connecting, you need a thread or a Go routine or whatever, green thread, to listen for data coming from the client. And you need one thread to send data back. And there's one more complication, because you can multiplex subscriptions over WebSocket connections. So essentially what it really means is, if a client makes 5 subscriptions over one WebSocket connection, what we really have is the client connects to the router, so one read thread. The router connects to the subgraph, it's a second read thread. And then for each of the subscriptions, we will have 5 write threads, because 5 threads wait for data coming somewhere or resolving that. So it's like for each subscription, it's another 5. So for 5 subscriptions over over one WebSocket connection with a regular model, it's already 12 threads that are running somewhere. Most of the time they are blocking because they do nothing. And there's one more thing that you should be aware of. For each thread, you usually have a buffer. So that means because you don't just read or write unbuffered from or to a connection, you usually have a buffer for that. So that means you don't just have 12 threads, but you also have 12 buffers. And this adds up quickly. Okay, so how do we solve that with our event-driven federated architecture? When the client connects to the router, we use something that is called KQ or EPOL. So instead of opening 5 threads or something, or a thread per connection to wait for the client to send us data, what we do instead is we put this WebSocket connection, we hand it over to EPOL, which means we give it to the kernel and we tell the kernel when the client wants to send us data, when there's data ready to be read on the connection, please inform us. And the kernel is very efficient in doing that. I'll show you in a second. And in addition, what we also do is we deduplicate the subscription handler. So when there's like 10,000 clients connected and they subscribe to the exact same thing, we handle this in an event-driven manner, which means we create one single trigger. And once this trigger is created, we simply wait for this trigger, and once new data comes up, then we take this data and distribute it to all the clients. So how does it look like in reality? If you go here, you can currently see I print out what's happening. So I can just restart this so we start from a clean slate. So yeah, 17 megs of RAM. You can currently see here we have no open connections, no subscriptions. And I have a little script here that starts 10,000 connections. So you can see lots of stuff happening here. We are now connecting with 10,000 clients. Let's see how far we got. We have open connections, 10,000 here. Where is it? Here. Active subscriptions, 10,000. Okay. And we add one more. 1 second. Here. Employee updated. Now it's 10,001. Here, 10,001. Okay, let's see how many Go routines we use. Top 5. 45 Go routines. And these are mainly like Go routine pools. So you can see that the number of Go routines, the number of threads, doesn't really scale with the number of connections. It's kind of independent. So we have some thread pools and it's quite efficient. The second thing, we can check our heap, top 5. And you can see we have 160 megabytes of memory, which is not so much for 10,000 connected clients. Okay, so here we have our subscription. Now I have this thing somewhere. Here's my terminal to send a message. So I have my subscription running here, and I want this to see what's happening here in the set. So I move this to the side. I want to get the update. I move this down here. And now we need to invalidate the topic. So we need to publish a message. We publish that. And you can see this is instant. Absolutely instant. So we send a bunch of messages. Each time we resolve 10,000 requests, We resolve each of the requests individually, simply because the client could have sent different headers or extra data that influences the resolver process. But in general, you can see when we send a message and you look here at the CPU, you can see the CPU quickly jumps to like 100% or something. So if we send something like 2 messages per second, you can see it's very fast on the response here. And we utilize 1 CPU to the fullest. Let's check the heap again. After sending some messages, top 5. Now the heap is at 188. So it grew a little bit, but not so much, because we're limiting the resources, how much memory we use to concurrently resolve. And we can also check the go routines. And you can see here this grew a little bit because we are dynamically growing our thread pools to 161, but it didn't grow to like 10,000 or more beyond that. So yeah, this is event-driven federated subscriptions. I'm curious what you think, and that's everything I wanted to show for the moment. This feature is available, it's open source. You can download the latest version of Cosmo, and if you want to get started, here is an example schema under demo, PKG, subgraphs, and then employee updated. But you can also go to, let me go here, Cosmo-docs. And then if you scroll down to event-driven federated subscriptions, here's extensive documentation, how to configure it, how to set up the event source. In this case, it's currently only supported with NATS, but if you are interested in other event sources, talk to us. Here's an example configuration, the semantics, how everything works. Yeah, that's it. I'm curious what you think, and looking forward to your feedback. See you soon. Ciao.